2, day 4. Yeah, it feels like we're almost done with the year already. It feels like I've learned everything I need to know about Algebra 2. I'm ready for that Common Core test. Okay, not even close. Not even close. All right, you guys ready? Mr. Key's ready. Let me put his name on here. Oh my God, Mr. Key. Mr. Key is ready. All right, so yesterday we talked about perfect squares, right? 1 squared is 1, 2 squared is 2, 3 squared is 3, 3 squared is 9, 2 squared is 4. I don't even know what I'm talking about. Today we're going to talk about cubes, fourths, and fifths. So the first thing we probably ought to do is start listing them out. Now, there's not that many of them. It's not that exciting. Not as exciting as the squares. Perfect cubes. The first perfect cubed is 1. Guess what the first perfect fourth is? 1. And the first perfect fifth? 1. 1 times 1 times 1 times 1 times 1 times 1. It's always 1. All right, now we're going to do 2. 2 times 2 times 2 is not 6. It is, in fact, 8. 2 times 2 times 2 times 2 is 16. 2 times 2 times 2 times 2. 5 of them is 32. So these are my perfect fifths, perfect fourths, perfect cubes. Now we're going to do 3. See if we can do this. 3 times 3 times 3, 27. 27 times 3, 81. 81 times 3, 243. Perfect fourths. 4 times 4 is 16. Times 4 is 64. Now 64 times 4, double it, 128, double it again, 256. Times 4, 1024. All right, I'm going to end on those fifths. That's 4 times, so this is 4 to the 5th power here. Pretty sure I'm right there. And I'll continue with the cubes. Fourths, I'm pretty much done with those two. No, I'll do one more fourth. 5 times 5 times 5 is 125. 5 times 5 times 5 times 5. 4 of them is 625. And I think, just for fun, I think this is 30. Oh, wait. 600. Oh, man, I think it's actually 3125. Probably should check that. Not that important. 3125. Let's see. 600 times 5 is 3,000. Yeah, 21. All right, so let's see. 6 times 6 times 6 is 216. 7 times 7 times 7. I've forgotten. I think it might be 729. I don't know. 7 cubed. 343. Man, I always forget that. Where am I going? 343. And who cares? All right, so I'm going to tell you right now, you're going to use 8, 27, 125 the most. You might get a 64 and you might get a 216. Of the fourths, probably going to use 81, 256, and 625. Those 3. Oh, and 16. Yeah, those 4. And then this fifth, this one definitely, and then this one. Probably not the other 2. We're not really worried about those. So let's talk. When we did square roots, if I did the square root of 9, I got 3, right? Because this is the same as 3 squared, and so the square and the square root cancel. This has got, remember, this is like a little 2 here, but we don't have to put it there. That square root and that square cancel leaves me x. So then when we did x to the 5th, we wrote it as an even x to the 4th times x. And then we said, oh, the square root of x to the 4th is x squared. So my answer is x squared, square roots of x. And that's what we did yesterday with perfect squares. Today, we're going to start talking about cubes. Well, this is really the same as the cube root of 3 cubed, which is just 3. Or the cube root and a cube cancel each other out and give me x. So what we're looking for here is not groups of 2 like we were before. We're looking for groups of whatever the root is. In this case, it's 3. So if I'm talking about x to the 7th, I'm going to rewrite this as a groups of 3 and then anything left over. So in this case, I can rewrite it as x to the 6th times x. Because isn't this really x cubed times x cubed, or 2 groups of 3? So the cube root of x to the 6th is x squared. So believe it or not, it's still x squared, square roots of x. Cube roots Oops, I should probably rewrite that. And I've run out of room somehow. Let me move down a little bit. I know there's not much below here, but erase that. So let me get rid of that. So in this case, the answer is x squared cube roots of x. And that's a real common mistake, forgetting to actually put the root there. Because if you just put if you forget that number, then you got to understand it's the square root, you know. So in this case, for fourths, we're going to be looking for groups of 4. And this is really equal to the fourth root of 3 to the fourth, because 3 to the fourth power, just like we talked about up here, is 81. So this is really just equal to 3. So in this case, we're looking for groups of 4, fourth roots, and fourths cancel each other. So this is just equal to x. And now let me do x to the 9th. I'm looking for groups of 4. I want to get as close to the groups of 4 as possible. So I'm going to rewrite this as x to the 8th times x. Well, the cube root of x to the 8th is x. Excuse me, the fourth root of x to the 8th is x squared, fourth roots of x. Again, the pattern should be, this should be easy. So this is 3. This fifth root and this fifth cancel each other out. Leaves me just x. And again, I'm going to do this one more time. X to the, now this is going to be interesting. I want to get groups of 5, so I want to get as close to that as I can. So that's x to the 10th times x squared. Sorry about this, not making this great. Well, the fifth root of x to the 10th, that is 2 groups of 5. That's x squared. Fifth roots of x squared. So when we're looking for perfect cubes, we're looking for groups of 3. In this one, we're looking for groups of 4. That's groups of, all right, this is groups of 2, groups of 3, groups of 4, and groups of 5. That's what we're looking for. So mostly, I'm just going to say right now, mostly we're going to deal with these two. Periodically, you're going to get fifth roots and fourth roots and fifth roots, but not too often. What about cube roots of negatives? And I think we talked about this the other day. I know we talked about it the other day in class. I'm not sure if your teacher has. But yesterday we talked about negatives under the radical when it's a square root, and we defined this imaginary number. I don't know what happened to my mouse. We defined this imaginary number I, and we said I is equal to the square root of -1, because I can't multiply two things. Remember, it's got to be two things. I can't multiply two things together to get -1. That have to be the same. So I couldn't do -1 times -1. That would be +1. -1 times +1, but those are two different things. Remember, we're looking for perfect squares, two things that multiplied together. So, but negatives are a totally different story. I know that -2 times -2 times -2 is -8. So if I'm looking for the perfect cube, the number that I can cube to get -8, my answer is -2. So you can take the cube root of negatives, because 3 negatives make a negative. So I want the cube root of -27. That's -3, because -3 times -3 times -3 is, in fact, 27. And I got another one over here, the cube root of -125. By the way, if it ends in a 5, it's probably going to be 5. In this case, it's not 5. The cube root of 125, the cube root of +125 is 5, but the cube root of -125 is negative. So what I want to remind you is you can take the cube root of negatives, not the square root, but the cube root. All right, let's move. We got it. Now, so the thing is, this is what we're looking for. We're looking for these numbers. So in this first one, we're going to look for a cube. So I said, okay, cube. I want to find a perfect cube. So you can go back to your list if you want, or you can remember it's 27 times 2. Cube root. Well, what is the cube root of 27? It's 3. So my answer is 3 cube roots of 2. Now the fourth root of 48. So I got to find a fourth, a number in my group of fourths that goes into 48. And I know it's hard to remember, but remember 16 goes into 48. It's that weird one. So 16 goes into 48. So we're going to rewrite the fourth root of 48 as 16 times 3. Well, the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. So this answer becomes 2 fourth roots of 3. So we're looking for a cube root. Again, if it ends in a 0 or 5, it's probably going to be 5. So, but I got to think about what's that perfect cube that gives that's got a 5 in it. 5 times 5 times 5. If you remember correctly, it's 125. And 125 times 2 is 250. Toes bother me. And what's the cube root of 125? It's 5. So my final answer here is 5 cube roots of 2. All right, now I want fifth roots into 160. Well, 5's not going to go into that. By the way, I probably should have said if it's going to be a 5, the last two numbers are going to be either 25 or 50. Or zeros. Or 75. Could be 75. Yeah, it could be 75. You're looking for let's just say this. If it's going to be 5, this is going to be either 25 cents, 50 cents, 75 cents, or a buck. Okay? 25, 50, 75, or double zeros. So we need one that goes into 160. I need one of these numbers that's going to go to 160. That's a fifth. Well, if you look on the list, there's only one number that's a fifth that's less than 160. It's 32. So the only number that could possibly go into 160 is 32. And if you figured it out, 32 times 5 is 160. The fifth root of 32 is 2, so this becomes 2 fifth roots of 5. All right, let's start talking about variables now. Okay, so in this one, we're going to look for groups of 3. So 27 is already a perfect cube. Oh, wait, this is great. I don't even have to rewrite this one. It's already written for me as I need it because, let me go into blue. 27 is a perfect cube. X cubed is a perfect cube, and I can't do anything with y, so I'm all set. So the cube root of 27 is 3. The cube root of x cubed is x. And then the only thing I got left under the radical is cube roots of y. So that was an actually easy one. That wasn't bad. This one here, I'm going to look for groups of 4. So I'm looking at 625. I know it's got to be 5, but let's go see. Maybe we can take a look at it, and you'll find out that, oh yeah, 5 to the 4th is 625. So that's already a perfect fifth. I don't know what happened to my mouse. There we go. That's already a perfect fifth. And I can't do anything with x to the 4th, but I can do something with y to the 6th. Oh yeah, so these are fourths, not fifths. So we're looking for fourths. So 625, that's already a perfect fourth. That's 5 times 5 times 5 times 5. X to the 4th is a perfect fourth. We'll leave that as x to the 4th. But y to the 6th we have to rewrite. Remember, we want to write it in groups of 4. So we're going to write it as y to the 4th times y squared. Let me grab my black pen. So the fifth root of 625 is 5. Excuse me, the fourth root of 625 is 5. The fourth root of x to the 4th is x. The fourth root of y to the 4th is y. And then the only thing I got left over under the radical is 4, the fourth root of y squared. And believe it or not, later on we're going to find out that's really just the square root of y. But you don't need to know that just yet. You may not know that this year. Got to look at the new curriculum. New curriculum's a little weird. Holy mackerel. 486. I need a fifth that goes into 486. Well, let's see. 486. Oh, look. If I double this, 243 times 2, doesn't that give me 486? So this is, remember, this is 3 to the 5th right here. So we're going to come back here, and we're going to write it as 243 times 2. 243 times 2, and now it's a to the, oh, can't do anything with the a's, a to the 4th, but b's we can, so we're going to write this as b to the 5th times b squared. And c is already a fifth, so we'll just leave it as a fifth if it ever comes back. C to the fifth. All right, let me grab my red pen. So the fifth root of 243 is 3. And the fifth root of this is b. And the fifth root of this is c. So my final answer is 3b, c. Fifth roots of, let's see what's left over. 2, a to the fourth, b squared. Computer's dying again already. This is a short day. I forgot we got a quiz this day. Got to make sure you remember that. All right. Looking for cubes. Oh, and we got negatives now too. So we're going to keep negatives because I can take the cube root of negatives. We're going to keep those around. So the perfect cube that goes into 24 is 8. So we're going to leave it as negative 8 times 3. M n cubed times n p to the 6. And that's okay. That is okay. So let's go grab a different color to knock this off. The cube root of negative 8 is negative 2. The cube root of n cubed is n. And the cube root of p to the 6th is p squared. And remember, this is a cube root. See, I didn't write that cube there? It would be wrong. As long as I put in my final answer, we'll be okay. 3mn. And there's my final answer. All right, 1250. Probably going to be 5. If you remember correctly, or if you want to go back up, the fourth root, the perfect fourth with 5s is 625. So 625 times 2 is 1250. Now we're looking for fifths, so m to the fifth is okay. N squared, can't really touch that. And p to the 20th is okay, because that's a multiple of 5. It doesn't matter, as long as it's a multiple of 5. Grab a different color. So the fourth root of 625 is 5. Oh, this is fourth root. Ah, I screwed up. Fourth root here. Let me rewrite this. I'm doing green. This should be m to the fourth m. So the fourth root of m to the fourth is m. Can't do anything with this m. Can't do anything with this n squared. But this 20 is 5 groups of 4. So that's p to the fifth. So my final answer is 5 m p to the fifth. Fourth roots of 2m n squared. Ooh, that was a tough one. All right, negative 216. That's a cube. That's already a perfect cube. If I come up here, remember, 6 cubed. Did I do 6 cubed? Right here. 6 cubed is 216. So that's already a perfect cube. So we're in good shape there. And I don't care the fact that it's negative, but I do have some other things I need to rewrite. So I'm going to leave the negative 216 there. X squared, can't touch that. Can't touch that. Y to the 6th times y. You got to split that up a little bit. And then z. So the only thing I really had to split up on that one was that y to the 6th and y. So the cube root of negative 216 is negative 6. The cube root of y to the 6th is y squared. And I'm left with cube root of x squared yz. Almost done, kiddies. I think. We got 2 rows left. Oh, I got those. Oh, yeah. Oh, yeah. I forgot about the fractions. All right, cubes. We're looking for cubes here. Oh, now, I want to show you something. I'm going to be careful with this. Do you see this negative? That really stands for negative 1. And negative 1 is a perfect cube. Negative 1 times negative 1 times negative 1. So you got to be careful not to keep that underneath there. Capital H cubed. H. Capital J to the 9th is okay. L is not. L to the 6th. L squared. And then K to the 6th is okay. So let me grab a different color. So the cube root of negative 1 is negative 1. The cube root of H squared is H. The cube root of j to the 9th is j cubed. Cube root of L to the 6th is L squared. And the cube root of K to the 6th is K squared. Cube roots of, what's left over? H L squared. Oh, square roots. Those are easy. We're back to square. You give me a square root problem, Mr. Grouse? I'm great with that. That's 25 times 3. But I'm looking for groups of 2 now. So n to the 4th, n. P to the 8th is okay, and I'm not going to touch that Q. Can't touch that. Can't touch. Why do I keep doing that? It's like addicting. All right, the square root of 25 is 5. The square root of n to the 4th is n squared. And the square root of p to the 8th is p to the 4th. Groups of 2. And I'm left with 3nq. And our final one is 162, and we've already done the 4th root. The only 4th root that's under 162 are 1 and 32. So I know this one has to be 32. And so it's 32 times... Wait, that's 5th roots. Ooh, wait a second. That's 5th roots. Don't want to do that. And that would be 160. That's not even right. What am I doing? Haven't done 162 yet. 4th roots. I need a 4th root. It's going to be 81, by the way. But I need a 4th root that's less than... So, what number was that? 162. So it's either got to be 81 or 16. And what you'll find out is it's 81. 81 times 2. So let me go back. 81 times 2. Almost got that one messed up. 81 times 2, because this the 4th root of 81 is okay. Now we're looking for groups of 4. C to the 4th is okay. D to the 4th, D squared. And E to the 12th is okay, because that's a multiple of 4. So 4th root of 81 is 3. The 4th root of C to the 4th is C. The 4th root of D to the 4th is D. And the 4th root of E to the 12th is E cubed. 4th roots of 2D squared. All right, you guys ready for some fractions? Yay, Mr. Grouse fraction! Now you're probably saying to yourself, wow, that was fun. Now how about a challenge? You asked for it. I give you radicals and fractions. Awesome sauce. I know, there's a commercial about that. All right, stop crying for crying out loud. You know, I can't even speak English. All right, we'll start with cube roots. We'll make this simple. We'll go like this. So don't worry about this fraction. It's just 1/2. Cube root. So the perfect cube that goes into 16 is 8. So it's 8 times 2. F cubed is a perfect cube, so we'll leave it. G, can't do anything with it. And H will split up. H cubed, H squared. So what is the cube root of 8? It's 2. Cube root of F cubed, it's F. Cube root of H cubed, it's H. Now we're going to multiply. So 1/2 times 2 is just 1. Well, they kind of cancel each other out then, right? So I get F, H, cube roots of 2GH squared. Now you can see why it's important to start being neat and seeing what isn't crossed off and what is crossed off. 250, you know it's going to be 5 probably, right? So negative 3/5 cube roots of, and this is going to be 125 times 2. Now we're looking for perfect cubes. F cubed, don't touch G. Why did I copy that over? It looks like I copied that over. H cubed, I made that easy. That was too easy. Maybe I'll make that harder in class. So the cube root of 125 is 5. The cube, we already did this. This is F, this is H. So 3/5 times 5, the 5's cancel. Or if you did in your calculator 3/5 times 5, you'd find out it's just, or negative 3/5 times 5, you'd find out it's just negative 3. FH, FH cube roots of that same thing, 2gh squared. Calculator, computer's dying, 2gh squared. All right, let's keep going. We're almost done. 27. So the perfect cube that goes into 54 is 27. 2 9ths times the cube root of 27. And we're looking for groups of 3 again. R to the 6 is okay, but t isn't. T to the 6, t squared. That gives me my t to the 8th. So the cube root of 27 is 3. The cube root of r to the 6 is r squared. The cube root of t6 is t squared. So 2 9ths times 3, you would find out that's just going to be 2/3. You can write 6 9ths if you want, but it's really just 2/3. 2/3 r squared t squared cube roots of, oh, I should have wrote this as 27 times 2, right? Because I got to make 54. It's 27 times 2. So 2t squared. Almost made a mistake. 2t squared. There you go. All right, so because I can simplify this, I'm going to simplify this before I start busting it up. And doesn't 10 go into 160? I don't think there's anything going to be left over in the denominator on this one. So 10 goes into 160 16 times. There's more f's on the top. I'm going to try to avoid writing. There's 6 more, so that gives me f to the 6, right? These 2 cancel and leaves me 6. The g's just cancel each other out, and this one's got 3 more, so I'll leave those 3 up top. So really what I end up with is, this is h cubed. 16 f to the 6th h cubed. Now, in order to save a little bit of time, I know this is 8 times 2. And then everything else is already written as perfect cubes, so I'm just going to start simplifying. The cube root of 8 is 2. The cube root of f to the 6th is f squared. The cube root of h cubed is just h. So the only thing left over underneath the cube root sign is that 2. And be careful where you write that 3. It's got to be written right in this little crux. Right? It's not good enough to write it, because if you write it over here, if you write it just a little bit over here, it's going to look like the exponent on that h, and we don't want that. Last 2 problems. This one's going to be different. We're going to have to play around with this one. Is there anything that can be simplified? D. Okay, let's do the d's here. Leaves me 8 d's on the bottom and 4 f's on the top. And now I'm going to split up. So do it real big here. Oops. I don't know why I wanted to do it that big. That's really big. So cube root. So I end up with 8 g h f cubed f. And on the bottom, 27 is a perfect cubed. 27 d to the 6th d squared e to the 6th e. So let's see what we got here. This one's not easy, and this one isn't the way I wanted this one to turn out. So the cube root of 8 is 2, and the cube root of this is f. So this gives me 2f cube roots of g h f. Cube root of this is 3, and the cube root of this is d squared, and the cube root of this is e squared. Cube roots of d squared e. And I just say, this isn't normally how we leave this problem. I did not write this problem correctly, so it's a poorly written problem. So let's just pretend like we didn't do that one, and let's do this one. Let's see, the top has more x's, it's got 6 more. And the top has more y's, it's got 5 more. So what I end up with here is the cube root of 81 x to the 6th y cubed y squared all over the cube root of 125. Well, my final answer then is, let's see, the cube root of 81. Oh, no, we don't know the cube root of 81. Shouldn't have left it as the cube root of 81 because it's really 27 times 3. So the cube root of 27 is 3. X squared y cube roots of 3y squared all over 5, because the cube root of 125 is 5. Wow, that was crazy. It's all those letters and numbers. Really what you're looking for are groups of 2s, groups of 3s, groups of 4s, and groups of 5s. And you have to get comfortable with some of those perfect cube numbers. That's it, kids. Hit the subscribe button. Hit the like button. If you got a lot out of this and you're not one of my students, you can also hit the donate button. Just call it the donate to Mr. Kraus. Can hopefully get a new computer someday so his writing looks better. I also could use a new one of these too. This is what I'm using to write on. It's called a Yugi, right? It's not the greatest. It's kind of a cheap version of it. I'd like a nice one of those too, but that's okay. I'm okay. I'm having fun. You guys having fun? I'm having fun. All right, guys. Catch you on the flip side. Bye. 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 I don't even know how to stop this thing. I'm going to stop it like this.